You guys eating? You're tired? Yeah, welcome. I'm Daniel Schneider. I'm a principal program manager in the Azure Machine Learning team. And I'm here with my esteemed colleague.
Yeah, I'm David Smith. I'm a cloud advocate at Microsoft, representing R. We have our costumes on.
Yes, so we're going to talk to you about choosing the best language for machine learning from R to Python. So as you can see, David's been working a lot with R, and he's going to represent the R side of the debate. It's not going to be a debate, though. But, and I'm going to be the Python side. So yes, but we want to get started by asking you guys, like, what do you prefer? Like, who's a Python developer here? OK, well, that's quite a few. And who has a favorite Python package? Like, shout it out if you have a good one. Anyone? So, I mean, everybody raised their hand, so they must know at least one or two Python packages.
Azure SDK.
You're disqualified. That's a great one, too, though. But anyone else? Anyone working with pandas or something?
Pandas. All right.
OK.
I'll take it out then.
You take it out.
Yeah, we can have a gift for the question.
OK, second one. Now you know there's a reward. Anyone else who actually has a package they want to name out? Yes. Second? Scikit-learn. Awesome. Large or small? Or medium?
There you go.
Medium, OK. Our medium is actually large because we have XL and L. But OK, so. OK, now over to the R side. Sorry. Maybe if you do R as well, you can qualify. So who's doing R? Who's been doing R? Who likes R? Who's been? OK, it's some people. Yeah, you have a T-shirt already. So, use it away. OK, so R packages. Who knows R packages? Data table. Data table.
Yeah.
It's my favorite package actually. That's true. Tidyverse. Is that a good one? You're the expert. OK.
Tidyverse, yeah. Who said Tidyverse?
OK, we do one more. One more. ODBC, really? OK. We'll help you. We'll help you circumvent ODBC. What size do you want? OK. So you get one of the XL ones. Okay. So. Yes, we will show you how. Even better. Great intro. I didn't pay that guy, but only in T-shirts. OK, so.
Switch behind you here.
Yes, so let's take a look at what we're going to talk about today. So we'll talk about Studio, which you may or may not have seen. There was a keynote yesterday by our VP, Eric Boyd. He was demoing the new Azure Machine Learning Studio. It's a really nice, immersive environment for the data scientists to do basically all their work in, or the majority of their work in, when it comes to the cloud, the Azure cloud. They're still going to use their own frameworks, and that we will show you as well. And then we will talk a little bit about data sets to basically how to bring your data into a machine learning training job or any activity you'll do, scoring as well, explaining a model. Like data sets will give you an abstraction to move your data around and not having to share the credentials around that are used to basically pull that data, and also to abstract away where the data is actually coming from. And then we have notebook VMs that we're going to talk about. We're basically going to use those all over the place. They're basically ready-to-go VMs. You just kind of provision them outside of the studio, and then you have the ability to just basically get started in seconds. Notebooks are also now part of the workspace itself of the UX. We'll take a look at that. That's new, and we will talk about
R.
Because that's a new feature, a new SDK that just came out, and that we want you guys to see as well. So let's get started by just showing you the new portal. So is this big enough? What do we need? Oh, that's the wrong direction. OK. Is that OK? You guys see? OK. So this is the thing, the new studio. And as you can see, it's like, it's outside of the Azure portal. We used to have basically, large subset of this functionality in the Azure portal itself. But data scientists basically gave us a feedback that it's a little too crowded over there. You can create SAP DBs and HANA endpoints and load balancers and stuff that doesn't really gel well with what the data scientist wants to do on the day-to-day basis. So we pulled everything that was basically for the data scientist out into this portal. And you can see you have like different authoring approaches here. I'm going to talk about them a little bit later. We have assets here, and then we have things to manage. So starting at the bottom, because you kind of need to understand the way it's layered, is, for example, here we have data stores, right? So this is kind of the lower layer of the abstractions that we need in order to be able to pass the data around to make it available to the right compute where it's needed in a uniform way. So for example, I have a SQL data store attached here. So that way, I have my credentials set up for authenticating against this SQL database. It's running in Azure as well. Or I have blobs here, an Azure Blob Store, Azure File Store. These are different types of data stores that I can pull my data from. So the next one up here, and we'll see how they get used in a little bit. And if we go up here, we have our computes. So computes obviously is a big thing in Azure. And it's a main reason why, or a big reason why people come to Azure to do their data science, because we have scalable cloud compute. So the first tab here is the notebook VMs. So notebook VMs, as I said, they are ready installed VMs. You really need to just click here, new, create a VM, and hit create.
Oh, Daniel, what's a DS3 v2 you just had?
Oh, yes. That's the VM type that we're actually using here. So I have different VM types for the virtual machines here. I'm just kind of creating a DS3 v2, which is a kind of a middle-of-the-road 3-core machine with, I don't know, somewhere in the, it's set at like 8 gigabytes of RAM or something like that. I also have like a nice beefy one here, the E16.
That'll be good for TensorFlow.
Yeah. Yes, this one actually, or for R, this one has 128 gig of RAM. So usually not the thing that you want to keep running every day. So I'm probably going to get in trouble because I left it running overnight. But anyway. But it's kind of easy to switch back and forth between these. So the NC6 here, which is a GPU machine, I shut that one down because I don't want to pay for it. Right now, I don't need it. If I need it, I can just bring it up again. And the nice thing is they all share the same file system for data file for the compute files, not the drivers, because obviously they are different between the different SKUs.
So if we're working on a project together, then we can share files between each other, even though we're working in different environments.
Exactly. So you got multiple people in a workspace. I should have probably led with that. Like a workspace is actually the place where the people on a team will collaborate in order to get a project done, accomplish a project. And so I can see here that David has got a David-server machine running, which has RStudio on it. And I've been spending kind of all the money on all the other ones. So that's a notebook VM. We'll go back to this, and we'll use it a couple of times over the course of this talk. So then we have training clusters. Training clusters are really good to set up as scalable compute for automation. So if you actually end up, you build your model, and now you want to put it in production, and you want to retrain it and make sure that you have like a reproducible workflow that you execute over and over again and not manually by the data scientist anymore, you want to send that to some scalable compute that scales up and down depending on the need. So if I create a new cluster here, foo something, you can see, again, I can pick a machine size. So let's pick something cheap this time. And then I can say how that cluster should scale. And I can say, OK, let me scale this from 0 to 100 nodes. So, and then now it's going to create a cluster for me. And to that cluster, I can send work. And if that work requires 5 nodes, it'll spin up 5 nodes. And when that job is done, it'll spin it down again. Yes?
But some of these clusters, you have 0 nodes. What does that mean?
That means that we don't want them to actually be running any nodes when there's no work on them.
So if you're not doing any work on the cluster, it scales down to nothing. You don't pay for any compute at all.
Which is kind of a great thing to do, certainly for automation, but it's also a great thing to do interactively if you're working with expensive SKUs. If you take like a V100, which is called here in this in the Azure world NC6 V3, that's about a $3.60 machine per hour. And so you don't want to really do interactive work with it, but you might want to do the interactive work on a cheaper machine. And then when you actually train the full data set, you actually send the job to a cluster that will then scale up, run the job, and then scale down again. It's a cost-effective way to, you're just basically not wasting any money on idle cycles of the machine. And then we have inference clusters here. Here we got a Kubernetes cluster where we can deploy our models to for inferencing. So once we train a model, we want to put it out as a REST APIs, behind a REST API so that it can be called by my app that's using it. Okay. And then attached compute, you can actually attach like an HD Insights cluster, for example, or other VMs here, so as a third or fourth option. Okay, moving up here are the endpoints. So these are the actual deployed web services or models as web services, as REST APIs. So if I take this one from the designer, it's particularly nice because it actually gives me the ability to test this in place. So I can have this model here that's predicting the attrition of an employee in my company or something. And there are all these features that the users or the employees have. And in the end, if I kind of run this through, the test is going to yield, okay, there's a 10% probability that this person is going to churn. And I also get a lot of information here on how to consume this in different languages. So it's kind of nice, including the authentication parts. We don't have this for the broader set just yet, but we'll basically get this kind of nice UX or functionality for all the models that actually get deployed to our service. Right now, it's only for the ones that are coming from Designer. Okay, and so now walking up here, we go to the models. So models obviously are the weights and biases that are produced by our machine learning computation run, right? So TensorFlow or something at the end, or scikit-learn at the end, what I get is, in the scikit-learn case, a pickle file. And that pickle file needs to be deployed somehow in order to run as a service. So if I go to like this model here, for example, then I can see how it ties over to the endpoint, right? So, and then if I go back here, you can see which run created this, this model. And then from the run, I can even see which data set was used.
So you can go all the way back up the stack. You've got a completely reproducible environment from an endpoint. You can trace back to the model that created it, the language code that actually trained the model, and even the data that actually generated that model in the first place.
Exactly. So I have like the full lineage, as we call it, of my model, that is, or my web service that's running a model. And I can trace it all back, which is a great idea if something goes wrong, I want to understand what happened, why was that, or somebody leaves the company, and I want to understand what did that person do, or they're just on maternity leave or something of that sort, right? So that's a great tool, or great for reproducibility, and also just basically being able to inspect what people have done. So if we walk up here, so we've looked at all these things now, and then we go to Designer. Designer is our drag and drop environment to author machine learning projects or models, like to create them and also to deploy them. As you can see here, it's a drag and drop environment. You can drag things around. You can produce or pull in new boxes, and you can kind of connect them here. So it's a way for people that don't know how to code or don't want to code to create a project and create a machine learning project. It still requires you to know something about machine learning, because you still need to know which boxes to pull in. So I'm using a two-class logistic regression here, comparing it with a two-class boosted decision tree. That is so at least you need to have some idea of what these things mean. You also need to have some idea what it means to split data.
Daniel, I don't think we're going to have time to go into all this in detail today, but there are other presentations we'll give you links to at the end of the talk today.
Yes, excellent. Tomorrow morning at 9 o'clock, Erez has a talk about this where he shows all the different authoring experiences in much more detail. Going to the next one, just real quick, automated ML. In the UX here, as it presents itself, it's for the what we call like the citizen data scientist, so somebody that is actually not necessarily a data scientist that is learning, or maybe is a subject matter expert. So here, all you need to do is actually go and take a data set, like again, let's take the employee attrition data set, and then you go and give it a target column that you want to predict. And then you basically set it off to run, and it'll go and create a bunch of models and compare them and give you the best one or the recommendation.
But Daniel, I'm a data scientist that likes to code. What do I do then?
Yes, so this is what takes us to the third and maybe first, actually, tab here, which is the notebooks. So the notebooks are running in, or they're hosted in the workspace itself. So the workspace has storage. This Ignite workspace that we're using here, that we're collaborating on, has storage, and in that storage we see these files. And so I can click on one here. This is my playground, and I can go and do some matplotlib plotting right there, right then. And it's actually connecting to this notebook VM. Here are all the notebook VMs that I have available to me, and I can create a new one here as well if I want to. And yeah, so you might want to know, would this work in R as well?
That's right.
Since you're an R person. So yes, it will. So here, this R dot version. So I can just show you the IntelliSense, how nice it works. And then you can plot histograms here. It's like fully enabled R kernel in notebooks.
A fully complete R environment up to all the latest version of R and all the packages.
Yes. OK, so after we basically run through all the tabs here, we're going to dive a little bit deeper into the data sets. And we'll see how one of those is created. It's really rather simple. I can do it just right here. In this case, I'm going to pick from data store. I could just upload local files. That's actually something that works quite well. So if you don't have like terabytes of data, but oftentimes your data is already on some storage, which means you'll pull it from a data store. You could also just point to web files, which is actually kind of convenient for stuff that public data sets like MNIST or some public well-known data sources. And we actually have a curated set of those as well already under the Open Datasets tab here, so you can actually pick from one of those. So what we're going to do, though, is we have our data in a SQL database, and we're going to call this foo. This is going to be a tabular data set. Tabular means it's a structured data set that has rows and columns. The other option would be a file data set. The file data set would obviously be like a collection of files. Which is, for example, if you have image processing, image recognition, you go with that. So and then we'll pick a data store. You've seen like I had a bunch of them further down. I'm going to pick this SQL server that I've set up here, and then all I need to do is just type in the SQL query here and hit next, and that will already give me like a view of the data, and I can make sure that I actually got the right query. And if I'm happy with this, I can come over to the next one, which looks at the schema. So here I can play with the types a little bit if I think it's got the types wrong. But since it's coming from SQL, it's actually doing a pretty good job of just mapping SQL types to pandas types, really, or our internal types. I can also turn off certain columns if I don't want to import them. I'll take this all and create this, and OK, so I already have this one registered. Let me just fix this real quick. Back.
You have another version out there already you can use, right?
Yes, I have another version that actually we're going to use, but there's some feature that we're actually going to remove where it's actually matching the exact same query. And if I already have this defined somewhere else, then it's basically saying, whoa, you already have this. You don't need to define this again. We thought it was going to be useful, but actually it's more in the way. So now that I changed the query a little bit, it now understands it's actually something different. And now I've created this thing again. So now I can go back to my notebook here and load this data. Oh, actually, what I wanted to show you here is if I'm here in this thing, there's actually the sample usage, so I can just take this and go to a notebook here, because we'll go back to my notebook playground. And then this will give me the code to load this data set into memory, into a pandas data frame. So it's really quite simple. You need, of course, all the information for this workspace. And then you create this workspace object, and from that workspace object or through this workspace object, you just get this by name, right? So all the data sets that are listed here, you can just basically get through the API as well, and that's kind of the point, right? So now I could do some, analysis here with this data set, but I'm not really so good with plots, and I hear that you're actually really good with that, David. So maybe you could help me with that.
Thank you for pointing the R guy for that particular purpose. So, Jenny and I are working in a team to actually build some models around this data. So I am here in the same machine learning studio, but we're in that shared environment as you saw. I could, of course, go to the notebooks, as Daniel did a moment ago, and use a Jupyter notebook with R to do the analysis. But anybody seen the presentation, I Don't Like Notebooks by Jill Gruss? Just do a search for I Don't Like Notebooks. I fully subscribe to this. And so I'm actually going to use the environment which I prefer, which is R Studio. So I can actually go into those same compute resources and launch R Studio, which is the preferred IDE for R developers for building models directly within my web browser right here. The complete R Studio environment ready for me to go. And as you can see, I already have some files set up for me to use. Let me go ahead and grab one of the files. Yes, that deserves a round of applause. This is a fully hosted, fully complete version of R Studio. And I'm going to start analyzing that data that Daniel has prepared for me. Do not let Jenny Bryan see that first line, for those of you who know the story there. If not, come and ask me later on. But all I need to do is load the brand new Azure Machine Learning SDK package, which has just been released on GitHub for R, which provides me a full programmatic interface into all of those artifacts and assets that Daniel was talking about just a moment ago. And
we actually just pushed it up to CRAN, so it's now on CRAN.
Wasn't yesterday, it is today. Thank the CRAN gods for getting that through. Awesome, so you can just load it straight from CRAN. I can connect to our workspace just with an object directly in the session right there. So now we are connected from R into the workspace. And now, let me read the data. Now, of course, I could use the ODBC package to connect to the SQL data store directly, but I don't know where this data came from. It's just been prepared for me by my team member. But now, using the SDK, I can access it directly as an object. It will actually expose the object to R to me as files. Because R, one of the easy ways to read data with file is just through reading CSV files. So now it's available to me, and now I have an object called df. I need to run that one again. It's a slight bug in that package in preview. And I will do my traditional sort of cleaning up of the data. Daniel, I noticed when you read in that data, you put all the numeric columns as integers, but some of these are actually categorical values. Okay. So I really need to convert these into categories so I can get some nice visualizations and analyses of these data. But with that done, I can just use RStudio's view function and have a look at that same data directly within my RStudio session right here, do all the usual things with that. And you requested a plot. So we'll do that in a moment. But first, let's just do a numeric summary of the data using R's built-in summary function. We can go up and have a look at all the summary statistics and tabulations of those data. One interesting thing you will see here is for one of these variables, employee count is always 1, so we're probably not going to use that in our model.
Only one employee in every line.
Apparently, yes.
Yeah, so it's a shocking revelation.
All right. But let's have a look at a visualization of the data using ggplot. I'm going to zoom into this plot so you can see it better. And what we have here is, this is about employees who either leave a company or stay with a company. Those on the left have left the company early. Those on the right have stayed with the company. Oh, other way around, sorry. Those on the right have left the company. For 3 different departments in IBM, human resources, research and development, and sales. Something you'll notice is those companies that have left the company tend to have left at an early age. That's also something you might expect. But also see the comparisons in attrition between those 3 departments. Pretty heavy, a lot of attrition rather in the sales department, which is also something you might
expect. Looks like when you're like 40-something, you don't leave anymore at IBM, right?
Yeah, you're a lifer by then.
That's it, right? You write it out.
Yeah, that's right. And Daniel, I know it's tricky to get nice charts like that in Python without a lot of code, so let me just save that to our shared file system for you so that you can use it in the report that you have to build.
Yeah, you'll see validation of that in my next part of the demo.
But Python
my plotting isn't very good.
Yeah. But Python can build a model on this data, right?
It can absolutely. So, but let's do like a quick recap of what we did in the data sets here so that we understand what really happened here. So the data sets, as you saw, they're typed references to data that's residing on a data store. So I have a data store. It could be blob, SQL, ADLS Gen 1, Gen 2, HTTP. And from that, I'm just creating either a tabular view of that data, if it's a CSV or it's a Parquet file or some other delimited file, or I'm just going to expose that as files, so as a file data set, right? So I can that way provide the user consistent access in different locations. I can use that on my laptop, on my local machine in the cloud. I can download it, I can mount it, I can get it as a pandas data frame. Soon we'll also expose it as an R data frame. So, and we're versioning this. You've seen that there was some intelligence in there that's maybe a little bit too intelligent at that point in time, that we actually look at other versions of the same thing. But in general, this is tied in with our full lineage. So you can see which run was actually consuming which data set, and then you can kind of combine this or combine this information into building like a full lineage from the data set all the way to the model in the service that's running it. And it's nicely integrated into our UX, so it's actually really easy to build these things on the fly in the UX and also through our APIs. Okay, so now, since we've got the data now and we have analyzed it and we understand it better, we're building a model. So we could do this in notebooks here. We can do it in Jupyter as well. But again, there's this thing, some people like notebooks and others don't. And especially when it gets complicated, when files get bigger, and you actually want to debug, you wish you had an IDE and you didn't do everything in the notebooks. And so that's not a problem because you can actually use Visual Studio Code. Now, since I would really like to use my big machine with 128 gigabytes of RAM, how do I do this? Do I run basically on there and then do like a Unix X server on my machine? No, not required, because Visual Studio Code has this awesome extension called Remote Services. Let me show you here. For remote development, it's actually Visual Studio Code Remote Development Extensions Pack. It's the full name. And once you install this, you actually get this new tab in here that shows you all the SSH targets that you have configured here. And this is my E16v3 machine. And if I click on this, it actually takes me right into the project that's running on that machine. So I have now the language services available on that machine, and it's basically using all the same, like as if I was actually running on that machine, but it's coming from remote controlled from my MacBook here, right? And so that allows me to do things like, oh, by the way, let me prove it to you. Host name here, type this. Host name is that machine, and if you go free, you'll see that this thing has 132 gig of RAM. So that's actually the cloud machine. But the experience here is actually really rather cool because I can just hover over stuff, and it's like as if it was all local, right? I get the documentation. I can also peek at definitions here. So it's really, I can jump to definition and jump through the code. And best of all is, as you can see from the pane here, I can actually debug this graphically. So I can just set a breakpoint here and then start the debugger. So now it's going to start up the Visual Studio Code debugger, a remote debugger basically on that machine, and I'll be plugging into this. So it's actually already running. It's now loading the data set. That is starting up a few threads, as you can see here, because the actual data acquisition happens out of thread. And then I'm in my breakpoint. I hit my breakpoint, right? And this is basically on a cloud machine. All I needed to do, make sure is that it has SSH configured. So now I can add a watch point here. I can, for example, this categorical variable. I want to see what's going on there. And let's see what the call variable tells me. and then I can step through the code as if it was local on my machine. And it's really blurring the lines between local development and remote development. Honestly, you forget pretty quickly that you're actually working on a cloud machine. It's so fast. It reconnects really well. At the beginning, it was a little bit flaky, but by now, it's like it reconnects. Like you shut your notebook, you open it up again, it reconnects, and you're just where you left off. It's pretty magic. Anyway, so now since we've debugged our model, well, all the way down here, you see it's a bit of a bigger file, so I really wouldn't want to do this in a notebook anymore. I'm actually registering this model in the workspace. So let's let this run. It's going to train now. And there you see, like, scikit-learn is also spinning up quite a few threads, actually. And now I have a model created, and it should show up in my workspace. So just before we go, and now we would actually deploy this model, there's multiple ways. I could just go back to the portal here, find the model that I just created. So here must be like the new version, 32. So that's the one I just ran, 245. Right, so I could go and click on this one and then start deploying it through here. But we also have a extension for in Visual Studio Code for Azure Machine Learning, which I have installed here. And that thing allows me to find my workspace. Oops. So
You got a lot of workspaces there.
I got a lot of workspaces. This is like, yeah, this is it's the Ignite one. I'm blanking. There it is, yes. There was a feature request I just sent to the team, like make it more visible what my active workspace is. So they're working on that. This is also in preview, so we'll need some more, we'll make some more improvements to this. But either way, my model is here now, and I can also go and deploy it from here. It's going to ask me some questions. Where do you want to send it to? Yes, I wanted to send it to my AKS cluster. What do you want to call it? And so on. And then in the end, I send it through and deploy it all the way to the web service as a web service on AKS. So that's basically how the flow works on the Python side without using notebooks. How would it look like on the R side?
Well, for one thing, I would try some different modeling techniques. So you've used scikit-learn to build a model from the IBM attrition data. So let me try something different. I'm going to use my favorite package in R to do machine learning, and that's the carrot package, and build an SVM model on that same data. So first thing I'm going to do, I closed my RStudio window a moment ago, but I can just click back here in my compute and get it back in. And just as Daniel had with Python in VS Code, everything is back to where he was. Same thing with me in RStudio. I'm exactly back to where I was before. It's a great way for preserving my state when I go home at night. Just come back in, open my browser, I'm straight back to work. Let's go ahead and build a few models. And once again, I'm going to be using the Azure Machine Learning SDK library to do that in R. Let's connect once again to our workspace in the cloud and connect to our shared data space. Remember we said earlier on that R is going to need the file as a CSV. So I'm actually going to put that IBM data in the shared workspace for me to use. Now I'm going to create a computing environment, a cluster, for me to train my model with. You can see a few things here. I've chosen the size of the cluster, just a standard D2, V2. And the maximum number of nodes is 1. I've chosen that because this is a cluster that I exclusively am using. But if I was working on a cluster sharing with multiple people, I'd probably want to have several nodes so we don't contend for the same resources. Or if I wanted to do a bunch of jobs in parallel, then I could submit them all at once and distribute my computation across the nodes of my cluster. The other thing to note is the minimum size of this cluster is 0. So once I do shut down my laptop for the night, all of those nodes in the cluster will deprovision, and I won't be charged for the time I'm not using them overnight. Having done all that, all we need to do to train our model on our compute cluster is to define something called an estimator, and that's a fancy name in Azure Machine Learning for the environment, defining all of the packages that I need with R to do my computation, and the script in R that will actually build my model, which in this case is called train.r. I'm just going to shoot right down to the end here just to show you something about what it's doing. It's partitioning the data into an 80% part for training and a 20% part for validation. And then I'm using the train function from the carrot model to build that SV model directly on the IBM data. Once that model has been computed, it's going to calculate the confusion matrix with the purpose of calculating the accuracy of our model evaluated on the validation data that we kept out. We're going to log that as a metric. Every time you do a computation in Azure Machine Learning, you can store any metrics you like. We're going to use those metrics to decide between all the team members and all the models that we build, which is the one that's going to go into production. And we can save any other metrics we like as well that might be necessary for our validation or deployment purposes. And we're just going to save that as an R object directly in the experiment that we have there. So having done all of my computations, we might want to decide to then deploy that model to the cloud. Sorry, one more part I wanted to show. I didn't actually run that computation right here, but what I can do is just define my experiment right here. And rather than running it and waiting for the results, let me just get the results from an old run, run number 2 that I did, and extract that accuracy statistic that came from a prior run that we did that we'll use in the validation process. But let's suppose that was the model that we actually wanted to deploy into production, or perhaps one of the models. That same process applies just here. We're using our package once again and connecting to the workspace. All we need to do is to register our model into the environment and define an inference environment. So in the same way we had a training file to do the actual experiment, we have a scoring file which is used to do the inference into production. And then I can deploy that configuration either to Azure Kubernetes Service or to Azure Container Instances. And in this case, I'm going to do it to ACI, because this is just a test deployment. I don't need the infrastructure to do that. If I was doing it at real production, we'd probably do it to ACS. Okay, and then with that, we can deploy our model. I've given it the name of attrition 4 in this case. We'll see that in just a moment. And then we can use that endpoint that we have just created after deploying it from any application that can connect to an HTTP endpoint. But I'm an R person, so let's do that in Shiny. If you haven't heard of Shiny, it's a nice deployment framework for applications in R. And in fact, just to show you that this is a completely independent environment, I'm going to switch to R on my desktop, R Studio on my desktop right now. This is running directly on this laptop you have in front of you right now. We have a Shiny app, which is basically defining the user interface and the functions that are going to be computed within that user interface, which in this case is going to call out to that endpoint that we just defined. So I can go ahead and run that Shiny application, and now we have a nice little app that we can use to test that attrition R deployment that I just made. The way it works is I can select any one of these rows of data, which come from the original IBM data set.
That app must be really complicated. It's got so many things going on.
It's actually really...
How many lines of code? How long did you spend writing that?
That's a really cool question. It's actually really simple. The only line of code that really does the work here that's not the Shiny app itself is about 20 lines of code, but the one that actually does the interface to the endpoint is this one, invoke web service.
Wow.
I just connected to my attrition R web service and converted the data that was selected from the table to JSON, passed to the service, grabbed the results. Super, super simple.
And the Shiny app only works locally?
No, the Shiny app can be deployed in Azure Machine Learning Services or your local desktop, but the way most people deploy Shiny is to an external endpoint running on a server because lots of people will be accessing this at once.
And so it'll also work in the RStudio server instance.
Yeah, it would work in RStudio server instance. But the really cool thing, Daniel, is that the way we have set this up is not just to run that particular model that we just published. We put a little field here that lets us select from all of the models that have been published to Azure Machine Learning servers, not just the R models, but also the Python models. So I can grab that same model object that you deployed from Python, and then from my R Shiny application, call into it in exactly the same way. So your Python code did the same calculation on the same data, but rather than returning 0 or 1 for attrition or not attrition, you actually return the probability. So I guess you win this round.
Awesome. But let's see who's got the higher accuracy, actually. Which model ended up being the better one? So if I just switch back over to my machine here. So you had a support vector machine, right? And that's what I get here is the 86% that we also saw on your screen. Mm-hmm. And let's see what my model gave. So 86.6, and here, metrics.
We didn't rehearse this, so I actually don't know the answer.
87.4.
Oh, it was a close run thing.
I don't actually remember what I put. Anyway, so obviously it's kind of within probably the statistical significance.
They're both good models.
Yeah, yeah. Okay, so I think that was all we wanted to show you. We've got 6 minutes left to wrap up. That's your machine.
Yep.
That is not going to work.
There you go.
Okay, so we talked about data sets. Oh, by the way, yeah, so there's like, I actually uploaded the slides also to the to this GitHub repo. So if you go to that URL, you can download the slides there as well. It's actually not visible right now. Oh, yeah, great slide layout. aka.ms/ and then this session code, BRK2019. That's the session. Okay, so we showed this. Just to wrap up, like how did this actually all play out? So we created a data set pointing to a SQL data source in the Azure ML Studio, tested it in Python, and then we used that data set in our Studio server running on the notebook VM to plot some charts. So we get some charts here. And then I went and created a Python model using the data set that we uploaded in Visual Studio Code remote, running on the notebook VM with 128 gigabytes of RAM, which all of which I, of course, needed for this huge data set of 1,400 data sets or rows. And then we created an R model using the data set in our Studio server using a compute cluster, right? So that's kind of that little icon there in the like left to the model. And then David created a Shiny app that would score both models in our Studio. And so we can kind of see the results.
Okay. That could have been a .NET app, it could have been a Java app, it could have been anything.
And let me just do some little closing on the compute instance or on the compute that we use. So notebook VM is what we're using today and what has been working for us really well. But we're actually creating a new version of notebook VM, and in the process, we're also changing the name. So look out for this in the end of this month or towards the end of the month. We'll have a new type of compute coming out. It's called Compute Instance. It is really a next version of the notebook VM, and it'll largely add these functionalities of that have an asterisk here. You can share compute instances. You can automatically provision them. You'll have RBAC control. You have VNet support, SSH policies. So those are those enterprise features that we're adding to make the notebook VM, the next generation of it, more enterprise friendly. You will still get the same pre-configured environments for ML. You will still get it to be fully customizable, meaning you can install drivers and kernel components at your heart's content, shut it down, bring it up again. It'll be there for you.
So basically, this means the data science department can talk to the IT department, and that actually be a happy conversation.
Exactly. Right. So you can say, okay, let me allow you to create machines that are not, within this range, right? So you can create maybe machines like in E8 that is like 60 cents an hour, but not necessarily the E16 that I was using, which more like $1.80 an hour or something, right? So that is almost all we had.
Except if you would like to try that brand new Azure R SDK, it has just been released to GitHub. You can find it at that link right there. Please do try it out. There is a little bit more work to do. You might have noticed the interface into data sets was a little bit difficult. That's going to be improved pretty soon. But we would love to get your feedback and comments, so please do that as issues on the GitHub repository. And as Daniel said earlier on, you can also get the Azure ML SDK package directly from CRAN as of today.
Okay. So here are a few more sessions for you to look at. Some of them have happened already. For example, Greg's session from this morning, but you can catch that on streaming, I guess. But then there's definitely something for you to check out tomorrow. If you're interested in Studio, go check out Erez's talk tomorrow at 9 a.m., for instance. If you're interested in more about the MLOps perspective, I recommend Jordan's talk, overlapping, unfortunately, with Erez's talk also tomorrow morning. And then there's more enterprise features being presented by Ashish at 1. So it's a bunch of interesting sessions.
But Daniel, we've forgotten one very important thing, the title of this talk. We said, like, you would come into the session, you'd know how to decide between using R or Python for data
Which
science.
one is the right language?
Well, the answer is you don't have to decide. I mean, that's the great thing about, we worked with a lot of data science teams when we were developing this. Teams are often very heterogeneous these days. You have Python developers, you have R developers, you have back-end DBAs, you have front-end designers, and all these people do need to work together. And now they can work in the same environment and share all those results, regardless of what technology they're using.
Yes. Any company, I think, of of like any enterprise, you can say, will always have Python developers and R developers. That's just a fact that we're actually coming across. It's just a matter of how many and how vocal each of those audiences are. But actually, we try not to be partial. We're impartial. We just give you the opportunity to use whatever tool you like.
So apologies for the bait and switch about the title, but thank you for coming. We've enjoyed being here.
Okay, thank you. So we have a few more T-shirts. If anyone is interested,
That's right. And we'll be right here if anybody has any questions. And as Daniel says, we do have more T-shirts available.
Which one? You can have a small, maybe?